Welcome back, students. In this video we'll be doing the first question of exercise 1.2. But before that, before we begin, exercise 1.2 deals with a very important concept which you'll be studying even at later stage, called the fundamental theorem of arithmetic. Okay, fundamental theorem of arithmetic. And it tells us that it's a theorem, okay, the theorem. It tells us that every composite number okay, every composite number can be written as a product of primes. And this factorization is unique. Okay, clear. Now so here what you have to understand is what is a composite number and what is primes. Okay, and what is I think you know product, right? Product actually means multiplication. So it tells us that every composite number can be written as a multiplication of primes. Okay, and this factorization, okay, whatever multiplication that you do is going to be unique. So what exactly is a composite number? Okay, so when we talk about composite numbers, we talk about numbers which can be multiplied not just by one and itself, but some other numbers as well. Okay, some other numbers. So in the sense, you agree with that? You can multiply that number with one, with itself, and even with some other numbers. So such numbers are called composite numbers. So for example, the first composite number that we come across is actually 4, because 4 is a multiple of 1. It can 1 into 4 is 4. 4 into 1 is also 4. But 2 into 2 is also 4. So 4 can be multiplied by not just 1 and itself, but also 2. In the same thing goes for 6. 6 is also a multiple. 6 can be, you get 6 by multiplying 1 into 6, or 6 into 1, or 2 into 3, and 3 into 2, right? Alright, so 6, 8. 8 is also a multiple of 1, 2, 4, and itself 8, okay? And such numbers are called composite numbers. Now when we talk prime numbers are those numbers which are a multiple of 1 and itself. Only 1 and itself. So 2, okay, 1 is not a prime number. So 2 is a prime number because 2 is a multiple of 1, okay, or you can get 2 by multiplying it with 1 and itself. 3 is also a prime number. 5 is a prime number, right? 7, 11, 13, 15, no. 14, no. 16, 17, and 17, 19, and so forth. These are all prime numbers, okay? Just remember, because 2, you can only get 2 by multiplying it with 1 or by multiplying it with 2, which is itself. The same thing goes for 3, the same thing goes for 5, okay? So once we're clear with what a composite number and a prime number, we can proceed with exercise 1.2. So this theorem tells us that every composite number can be written as a product of prime numbers. Clear? So 4 can be written as a product. That means it can be written as a multiple of 2 numbers, and 2 and 2 are both multiple numbers. The same thing goes for 2. 2 can be written as a product, means it can be written as a multiplication of 2 numbers, and those numbers should always be a prime number. Okay, so 2 into 3 is going to be 6, right? And 2 and 3 are both prime numbers. Same thing goes for 8. 8 can be written as a product of prime numbers, which is 2 into 2 is 4. 4 into 2 is 8. Now 2 are all prime numbers. Same thing goes for 9. 9 can be written as 3 into 3, whereas 3 is a prime number again. So these are just some examples of what this theorem means, okay, that every composite number can be written as a product of primes. So quickly we'll move on to to this question, which tells us to express each number as a product of its prime numbers. So for me, the way to go about is, I first check out which numbers it ends with. So if there's any, if the number ends with a 0, with a 2, with a 4, 6, 8, or all multiples of 2, I usually write it this way, okay? So what I mean by this is, if a number ends with 0 or 2, okay, I multiply directly straight forward with a 2, because you understand, you'll just write it here. You can write this as 2 7 times 40, right? Now it still ends with 0, so that means it can still be divided by 2. So 2 times 3 is 6, and 2 times 5 is 35. Apart from that, 5 into 7 is 35. So if you look into this, the prime factorization of 140 is going to be 2 into 2 into 5 into 7. Okay, and then you just check, is 2 a prime number? Yes. Is 5 a prime number? Yes. And it's 7 a prime number? Yes. Do not make the mistake of writing this 2 and 2 as 4 into 5 into 7. Okay, it will be wrong because 4 is not a prime number, and they have clearly mentioned here that we're asked to write it as a product of prime numbers only. So you'll have to write it this way. Okay, 2 into 2 into 5 into 7. The next question that will go forward is 156. Now the same way we'll begin it with 2 because the number ends with a 6, right, which is a multiple of 2 again. So 2 into 7 gives you 14. So 2 into 8 gives you 16. Now 2 into 3 gives you 6. 2 into 9 gives you 18. Now 3 into 13. So the prime factorization of 156 is going to be 2 into 2 into 3 into 13. Now you'll have to multiply, obviously you don't really have to, but 13 into 1 is in itself again just 13 itself, so there's absolutely no use for you to proceed after this step. Okay, so 2 is a prime number, 3 is a prime number, 13 is a prime number. So this is how you write a product or a composite number as a product of primes. We'll go with the next number, which is the third, and that is 3825. So with such numbers or any numbers that usually ends with a 5, I start working these numbers with a 5. I tend to work with 5, and we also know that 5 is a prime number, so you can always write 5. 5 times 7 is 35, so you're left with 3. So 5 times 6 is 30, and 5 times 5. Since this number ends with a 5 again, it's obvious it can be divisible. It is a multiple of 5. So 5 times 1 is 5. 5 times 5 is 15, so you're left 25. So you're left with 1 5. So this is going to be 153. Okay. Next, 3825, and 5 times. Okay, wait. 5 times 1. Okay. Next, let's just see. Okay, I think I see 3 is a multiple of 3 times 5 is 15. 3 times 1 is this. So I think that is it. 51 cannot be a multiple. 51 is again. It's going to be a prime number. Okay. So the product of primes for 3825 is going to be 5 into 5 into 3 into 51. Okay, 5 into 5 into, okay, oh yes, sorry, you can further, okay, I can see a possibility again. Okay, so you just keep on checking. Okay, you just keep 3 times 1 is 3, so you're left with, and 3 times 7, so I think that's the answer. Okay, into 3 into 17, just to be sure, because 51 is clearly not a prime number. Alright, so you're getting this as, you can always rewrite and write this as 5 square into 3 square into 17. Okay, you can write it this way, but you cannot write it this as 25 into 9. Okay, clearly because 9 and 25 is not a prime number, so you'll have to again factorize even 25 and 9. So you can write it this way, or you can write it this way. The next question is a fairly easy one, 5005. So with this kind of questions, let's straight away begin with 5. Okay, so 5 times 1 is 5, and 5 times 1 is again 5, right? Then I think this can be a multiple of excuse me, with 7. 7 times 1 is 30. 7 times 1 is 7, so we're left with 3. 7 times 4 is 28, and 7 times 3 is this. Next, I do see a possibility with 13. 13 times 1 is 13. 13 times 1 is 13. So the prime factorization of this is 5 into 7 into 11 into 13. Okay, I'll just write it from ascending order, from small to big. Okay, so the way to get good at this is to be very good with multiplications. Okay, not just for the not up to 10, but maybe even 11, 15, 16. If you can, up to 20. If you can remember all the multiplications, will be really helpful. Okay, so let us go with this. Okay, 7, 4 to 9. Now, this is a very huge number, and then if you really look into it, it's not a multiple of 2, neither 3, 4, 5, 6, 7, 8, 9, okay? In fact, you just keep on going. The first multiple that you'll come across when I did this was actually 17, okay? And you must remember, we're talking about factorization of prime numbers, so the factors will only be prime numbers. So when you're trying to find out what 7429 can be or what is, what divides 7429, you should only think of prime numbers, okay? So you should only think of 3, 5, 7, 11, 13, 14, 15, 16, 17 and so forth. Only these numbers, okay? Clear? So that you don't have to waste your time, because imagine if you keep on multiplying with a 4, 5, 6, 7, 8, all of that, you just end up wasting time. So only think or check if the number is going to be divisible by any one of the prime numbers. So it was 17 in my case. So 17 times 4, I got it as 68. You can always take a division here, okay? But I got it as 437, and then later I got this as 19 times 2 is 19 times 2 is 38. Okay, so 38 minus this, I got it as 57. So 19 times 3 is this. 23 cannot be further divided because it is in itself a prime number. So this is going to be 17 into 19 into 23. So the prime factorization of 7429 is 17 into 19 into 23. Alright. So for questions like this, you really have to be good with multiplications. Alright. So with this, we'll end the video for